Hello out there. I would like to introduce you to our physics project. My name is Morkos Nakla, and I will be the one to primarily guide you through our project. Now, the idea of our project concerns power. We know that a certain mechanism that changes energy or does work over time has power. But the question we had is that does this power remain consistent for any amount of energy? Our hypothesis was that power will remain constant. And to test this hypothesis, we needed a simple mechanism that had a certain power. We needed an affordable energy source, and we decided that gravitational potential energy would be best, especially since height would be the determining factor for the amount of the energy available. And we also needed a constant force to act over some distance to place or to do work to change that energy. And there's no better force than friction. And of course, time. It turns out that a change of energy from an easily calculated amount to zero is easiest and gets the job done. And since energy is a scalar, we did not need to worry about direction. The experiment itself consisted of dropping a ball in a parabola-shaped structure made from a clear tube from various heights and measuring how much time it takes to stop, or how much time it took for the work to be done. Now, as the height increases, so does the potential energy,
Yep.
as potential energy equals mgh, the mass of the object times gravity times the height. In our initial experiment, we had a small 3-foot tube, and we dropped a small metal ball from the parabola-shaped structure and only measured the various times it took from 3 different heights. To improve the accuracy of our results, the second time we performed this experiment, we used a much larger tube and accurately measured several different heights, 10 to be exact, and we measured the 10 heights 3 times each, so a total of 30 times. However, to perform such an experiment on a large scale, we needed various instruments to ensure the stability of the experiment, including a metal lock to be a weight to hold the parabola shape in place, as well as a magnet so the metal ball is able to be released at the correct time. Thus, as you can see, the experiment consisted of holding a magnet in place, which holds a metal ball inside a clear plastic tube in place. The plastic tube is held in a parabola-shaped structure that does not change for any of the trials, or at all for that matter. Moreover, as soon as the metal ball is dropped, a timer begins, and until the ball comes to rest at the bottom of the parabola, the timer counts the seconds, or measures the time that the ball takes in losing all the energy, whether through rotational or translational motion, that it had at the beginning of. This is a short representation of the experiment as a whole. As you can see, the ball drops from a certain height, from various specified heights, until it stops, following this parabola-shaped structure signified by the red arrow. It stops at the center, marked by the line of 59 centimeters. This is the data table and graph of our old results. The new and improved experiment has this data table and this graph. In any case, in both experiments, we were able to conclude the same conclusion. We are able to say that our hypothesis was correct, and that the power of a mechanism does not change despite any difference in energy input, because the time it takes for the energy to be lost will balance out and provide the same power. We are able to conclude this because, according to the graph, the function is a linear function. This is seen through the equation and the r-squared value. The closer the r-squared value is to 1, the more linear a function is. Our r-squared values were very close to 1, our worst one being 0.85. This shows that the function in incorporation of all variations of both experimental errors as well as human errors prove that power in fact does not change.
Thank you for watching, and I hope we have benefited you all.
Thanks for watching. We hope you learned something.
If you enjoyed our video, please subscribe to our channel.
Yep.
In this channel, we will be posting videos concerning other physics projects. Please follow us. We are Marko Snakla, Matthew Mankiewicz, and Brandon LaRouche. So please subscribe. Thank you for watching.